Yes, hey Elite Code fam, welcome back. And now let's solve the problem container with most water. And yeah, this is also a pretty straightforward problem. Let's go through the problem statement once. We'll be given an array of called heights, which will contain height of blocks, and each block will be separated by a space of 1. With the spacing between each block is 1. Be careful of that. And what we have to tell is, if we fill water, then which container or which two blocks can hold the most water. And yeah, if you know how to calculate area of a rectangle, this will become really easy. So yeah, like how do you do? That's what you ask. Okay, let's go through the first example. What will be okay? Again, this is the two-pointer approach, and I hope you know how that works. And it is a yeah, this can be technically called a sliding window also because we keep track of a specific window. And yeah, sliding window is a subsection of two-pointer. So how to do it? First, we'll initialize two pointers, left and right, one at the beginning and one at the end of the array. And then we have to calculate how much water that container can hold. So how can you calculate that? Consider this. Yeah, the first index, the length is 1, and the final index, the length is 7. So yeah, how will you calculate how much water it can hold? Yeah, it's pretty simple. First, we have to calculate the distance between the indexes, between the 2 points. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8. So yeah, the distance between them is 8, and then you will multiply it with what is the area of rectangle? It is length into breadth. Yeah, this will become the length itself. But how will you calculate the breadth? The length is 8, but to calculate the breadth, you have to be careful again. So what will happen is, while calculating the breadth, you can't multiply it with the biggest number, because if the container was 1 and 7, then when you add water to that, the water would flow out of 1, and container would hold only one level of water, not 7 levels. So be careful of that. 8 multiplied by minimum of the index value, so 1 and 7. Yeah, that is how we calculate the area. It's pretty straightforward, and the answer will become 8 7 is the oh, not 8 7, that's the minimum water it will hold is 8, because the minimum of 1 and 7 is 1, and the value over here is 8. Okay, now you got the value of 8, but now you have to update the pointers. Like, how will you do that? If there is a small length and a larger length, then in future it is pretty obvious that any point where the length is larger will obviously hold the most water. So we will take the pointer which is smaller and then increment that or decrement that accordingly. If it is left pointer, we will increment it, and if it is right pointer, we will decrement it. And yeah, after first iteration, we see that 1 is less than 7, so we'll increment the left pointer by 1, and the value will become 8. So again, we already have the value 8 stored in the answer, and again the two pointers are 8 and 7, and the indexes are and the distance between the index is how much? 1 1 2 3 4 5 6 7. Yes. And so yeah, how much water will it hold again? So it will be 7 multiplied by minimum of 8 and 7. And what is the value? 7. It is 7 multiplied by 7, which is 49. And there you go, you have your answer. Because we have the input array, we directly know what is the answer. But yeah, let's continue. And if both the values in this condition, we'll again take the smaller pointer and increment it over here. So it will become 3, and again 3 multiplied by 7, 3 and 7, the minimum will be 7, and the minimum will be 7, the minimum will be 3, and the distance is 6, and 6 it will be 18, and 18 is obviously less, so we'll increment the smaller pointer again, and now we see that both becomes equal, and when both becomes equal, we can increment any pointer, it does not matter. And yeah, the distance is 1 2 3 4 5, the distance is 5, and 5 multiplied by 7 is 35, and yeah, 35 is obviously less, so we can increment any pointer. So yeah, now let's change up and increment left, and when you increment left, it will, the two pointers are over here and here, and the minimum is 6, and the distance is 1 2 3 4, 6 for the 24 lesser. Again increment this, and that again you will have this pointer, and the minimum is 2, and the distance is 1 2 3 4, 4 to the 8, and then increment this, the distance is 2 and the minimum is 5, so this container will hold 10, and then you increment this again because this is smaller than this, and yeah, this will only hold 4 units of water, and the highest value I held was 49, and we can directly return that. I hope you understood how to calculate the area and all. Yeah, if you know how to calculate the area and two-pointer approach, then the algorithm becomes pretty straightforward. So area is 0. Initially, we consider that we have 0 units of water in the container, so we'll have 2 pointers. Yeah, and we will do while left is less than or equal to right, or we can go till while left is less than right. So there is no need to go till equals to also. And because if there is only one point, like what water can you hold? No water will be held over there. And while left is less than right, what you will do? Okay, I think there is some small indentation. Yes, while left is less than right, you have to calculate the current area equals, how will you do that? It is minimum of the 2 pointers or the heights at each indexes. Heights at the position left and English is hard. The index right, and you will multiply it by r minus l, the distance between each point. Then update the area. And if now we have to update the pointers, so we have to take the the pointer which has a smaller value and increment it. So if heights at the position, it is height, not heights everywhere. Be careful of those things, you will not understand what happened. Height at the position L, if it becomes less than height at the position R, then what you will do? Just think over it once. Left is less than right, so we will increment left, or else we will increment right. Even if you add equals to over here, it won't make any difference. And this is basically the entire algorithm. We can return area, and let's check it out once. See, r minus is equal to 1. You can't go out, it will go out of bounds when you do r plus is equal to 1. And yes, the algorithm was pretty straightforward. If you just knew how to calculate area of a rectangle and all, the question is like super straightforward. And there are so many submissions with the same code that my code got pushed to the end. And how LeetCode time complexity works is that it depends on your network speed, and I think my network is not that fast now, so it is pretty bad. So and yes, thank you for watching till now, and good luck cracking DSE. Let's go. Let's achieve greatness together.